Looking at 8.1 today, relations and functions. We're going to learn some words, and we're going to learn these words by doing. We're going to see relations, we're going to look at functions, and we're going to, I think the main part of this section is basically understanding these words, what they are, and how to tell if a relation is a function. But just a very basic beginning introduction to relations and functions today. But that brings us to our first word, which is relation. And it is basically, we're looking at this word, and if my pen will work, we'll see. Yes, relation is the pairing of numbers in one set called the domain. That's something you're going to hear a lot. Good word to know. With numbers in another set called the range. That is a relation. Okay, I've got a set of numbers here, I've got a set of numbers here, and I pair them together. The domain here, the range here. And what I get when I do that is called an ordered pair. Okay, so if I take one number from this one, let's say it's got a 1 in it, I take one number for that one, I pair them together, I've got an ordered pair when I do that. Okay, that's a relation. Each number in the domain is called an input. Each number in the range is called an output. Another way of saying that is the range are numbers that are dependent on the domain. It's kind of like a recipe. What comes out of the oven is very dependent on what you put into the recipe. So the domain would be the ingredient. The range would be what comes out. Does that make sense? So this is totally dependent on what this is. Okay, that's what you'll also hear me talk about dependent and independent variables. Well, dependent, the range is dependent on the domain. This is independent. Domain is something we choose. The range is something that happens because of the domain. Okay, we'll see that later. For a relation represented by ordered pairs x, y, the inputs are the x coordinates. That's the independent variables. The outputs are the y coordinates. That would be the domain. So we always say x is the range. X is the domain, y is the range. In another school, we called it domex instead of domain to help kids remember, and we called range rangy, ending in a y so that they could remember that. Let's go to the next page. Identify the domain and range of the relation. Let's look at this relation. We have a table. We have an age and alligator length. Well, this is telling us x and y. Generally, in any table you look at, the top is going to be x, and it's going to be the domain. The bottom will be the dependent variable, which is y, and will be the range. So the way we would do that for this one, and we would say domain equals, or we can just put a colon and separate by commas. Okay, we just list them. Then we say the range, colon, and we just list the numbers, hopefully in numerical order, and these are in numerical order, 61 and 73, and we're done. This was the range, this is the domain, and notice the length is dependent on the age of the alligator. Okay, the length is dependent, so this is the dependent variable, this is the independent variable. So we choose an age, and then the length is dependent upon that age. Okay, so domain x, range is y. Let's look at this. What's the domain of this relation? Okay, well, choose the x values. Here, 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 and here. So that's 0, 2, 3, and 5, separated by commas. The range would be the y values in this thing, which are here, 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 and here. So I've got 1, 4, and 7. Notice I have 4 twice. I do not have to write 4 twice here. I can just write it once. Let's do the next one. Domain is, let's see, I've got -1, -3, and +6. The range would be, let's see, -1, 0, 2, and 4. And I'm trying to put it in alphabetical order. I'm sorry, numerical order. Okay, and I'd like you to do that when you do it also. Okay, relation is a function. Now this is a word you're going to hear a lot. Function. And I wish I'd have circled it better. Let's try that again. My hand got away from me. A relation is a function if for each input there's exactly one output. Meaning, okay, x is the input. So if I have an input with an out, let's say I have the input is 1 and the output is 2. If I have no other inputs that match this one, I've got a function. But if I've got another input of 1, but it gives me a different answer or a different y value, this is not a function. So I can't have 1 paired with 2 and then 1 paired with another number. Okay, so if I need to have, for each x value, I need to have exactly one y value. I can't have an x value paired with one number and then the same x value paired with another number. Okay, so for a function, for each input, there's exactly one output. In other words, for each x value, there's only one y value. So let's read this. Represent the relation as a graph in a mapping diagram, then tell whether the relation is a function. So to represent it as a graph, we're just going to graph the points. So I've got negative 1, 1. That means I'm somewhere right in there. Then 2, 0. 1, 2 zeros right here. 3, 1. 1, 2, 3, 1. 3, 2 is right here. And then 4, 5. 2, 3, 4, 5. Okay. Now let's do it. I'll show you what a mapping diagram is. Mapping diagram, you have two ovals like this. The first oval is x, the second oval is y. So with the x, I'm going to put the x values in there in numerical order. So we got negative 1, 2, 3, and 4. In here, I'm going to put the y values. It looks like I got 0, 1, 2, and 5, I think. 0, 1, 2, and 5. Yes. Okay, now I just draw a line. So negative 1 is paired with 1. I have an arrow. Let's do that again. I got crooked. Okay, I've got an arrow going to the 1. 2 is paired with 0 in the second one, right here. So I've got an arrow going to that. 3 is paired with 1 and 2. So you got 3 going to 1, and I've got 3 going to 2. And then 4 is paired with 5, so straight over. Okay, that's how you draw a mapping diagram. This is how you show a relation in a graph. Now, is the relation a function? Well, notice I have 3 paired with 1, and I have 3 paired with 2. In other words, I've got my x repeats, and it's paired with different numbers. This is not a function. I can't have 3 paired with 2 different numbers, okay? 3 must only be paired with one unique number. Now, it doesn't matter that I have y values that repeat. Notice I've got the same y value here and the same y value here. That doesn't matter. Okay, I'm only looking at x values when I'm determining if something's a function. If I see x repeat, I'm looking and I'm seeing that this x is paired with 2 different numbers. It's not a function. Next one. Represent the relation as a graph in my mapping diagram. Tell whether the relation is a function. Okay, let's do one of the, for time's sake, let's just do one of these. So I got 0, 3. I've got 1, 2. I've got 2, negative 1. I've got 4, 4. It's at 4, 1, 2, 3, 4, and then 1, 2, 3, 4 up here. And I've got 5, 4 right there. So again, this is x and this is y. I'm going to have 0, 1, 2, 4, and 5. Then for the y values, I got negative 1, and it looks like I got 2, 3, and 4. Okay, 0 goes with 3. 1 is paired with 2. 2 is paired with negative 1. 4 is paired with 4. 5 is paired with 4. Is this a function? Well, let's look at the x values. Do we have any of the same x values here? Got a 0, 1, 2, 4, and 5. Nope. No, I don't have the same x values anywhere, so it is a function. It is a function. Let's look at the second one. We're not going to do a mapping or a graph, but let's see if it's a function. I've got a negative 2 here, notice, and a negative 2 here. So I've got the same x value paired with 2 different numbers, not a function. In other words, I have x repeating. Okay, next. When a relation is represented by a graph, you can use the vertical line test to tell whether a relation is a function. Okay, the vertical line test says that if you can find a vertical line passing through more than one point on the graph, then the relation is not a function. Otherwise, the relation is a function. So here, I have a vertical line. Okay, so I'm just going to grab it. Can I move this vertical line? Can this vertical line pass through more than one point at any place on the graph. Here it only passes through 1. Here just through 1. Everywhere I put the vertical line, it's only passing through 1 point. So because of this, we're going to say that this is a function. Okay, because of the vertical line test. Let's take a look at another one. Okay, here I have a vertical line. Okay, I'm going to pass it on the left. 1 point there, 1 point there. It only passes through 1 there, 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 and there, there, there. Okay, no matter where I put it, it only passes through 1 point. So the one on the left is a function. But let's move it down here. Let's look at the one on the right. Okay, 1 there. I'm only, so far, notice here that it passes through 2 points. Because it passes through 2 points, and this is not a function. A vertical line cannot pass through more than 1 point. If it does, it is not a function. So this is a function. This is not a function. Okay, and all it has to do is once, right? Let's look at the next page, and I think that's probably all we're doing today. Okay, so we looked at relations, we looked at functions, we looked at ordered pairs, input and output, dependent and dependent. So those are words that we need to know, and we need to be able to look at relations and determine if they are functions today. And that is it for our introduction to relations and functions.